I know Justice League came out a long time ago, and it's mostly a bad movie, but it has its moments. What I love most were some of the visual effects, especially what they did with Cyborg and The Flash. And I keep coming back to The Flash because the visual effects team tried for some stylized realism, which is definitely what Snyder was trying to do with his movies. And I haven't seen it in any other speedster in either live action or animation. One of the first things I noticed was the way the air moves. It's distorted and looks more like The Flash is underwater than running through the air, but that's part of the realism. Air is a fluid just like water, and we usually don't experience it unless we're at high speeds, which is why drafting is a thing, and airplanes and cars have to be aerodynamic. Also, it's why you feel that pushback if you ever stick your hand out the window of a car. Drag is what causes this, and the formula for drag is drag force is equal to the drag coefficient times area times rho times velocity squared over 2. I know this is a lot of information, but all you need to know is that velocity is squared. Any increase in speed is squared, so as one's velocity reaches higher and higher, like for the Flash, drag becomes more significant and the air starts pushing back more and more. Hence, it looks like a fluid. Next is this rainbow effect you get every time the Flash runs. What this rainbow means is that you're seeing the entire visible light spectrum, which means that compared to the Flash, light no longer seems still. In everyday life, we never actually see light travel because it's too quick for our eyes to perceive, but here we can see it moving just faster than the Flash. He can't go faster than the speed of light because that's impossible, and also it would be impossible to visually represent because the way that we perceive information in movies is through the cameras capturing light. Now, along with the spectrum, you also get blue and red blurs behind him as he runs, which maybe I'm projecting here, but I think is a really cool way to apply the Doppler effect from astronomy. Essentially, in astronomy, when we measure the light of stars, we compare them to different levels based on spectral lines. Spectral lines are specific levels and numbers that you get from different elements, and they're universal across, the universe. So when scientists discovered that these numbers were slightly off for some distant stars, they had to apply the Doppler effect. You know when a car with a siren drives past you and it starts to seem louder and higher pitched, then when it passes by, it goes back down?
Right.
As objects move towards you, their light becomes slightly more compressed, resulting in higher frequency or blue shifted light. Or when a star is moving away from you, the light becomes elongated and lower frequency, or redshifted light. Normally, this isn't something that you can observe with the naked eye and has to be done in a lab to notice these small differences even in stars, but what if someone was going near the speed of light and they're really close to you? Wouldn't their light be slightly redder when going away from you and slightly bluer when heading towards you? Lastly, this is something that isn't really represented in the film, but it's a cool equation and I'd like to try it anyway. Anytime an object travels at or near the speed of light, they experience time dilation. You're actually experiencing it every time you move at all, but never on a level that you can tell or that it matters. That's because the formula for time dilation is t prime, or time experienced by a spectator, equals t, time experienced by the thing moving, divided by the square root of 1 minus v squared over c squared, where v is velocity and c is the speed of light. So if you're going, say, 90% the speed of light, like the Flash is, I'm just assuming here, then for every 1 second that he experiences, everyone around him experiences 2.29 seconds. Normally, this is an issue because I'm sure that the whole returning the sword to Wonder Woman thing took about a second from the Flash's perspective, because what we saw in the movie was played in slow motion for our benefit. But if he were to race Superman for an hour, then he would have experienced 1.29 fewer hours of time than everyone else once he stops running. That means that if he were wearing a watch while running and he starts at noon, then when he stops, his watch would read 1 p.m. But everybody around him would have experienced more time, and their clocks would read 2:17, assuming that he stops in the same time zone that he started in. I know this is confusing, but if he ran for long enough, he could essentially age less than everyone else everywhere else because he would be experiencing less time. But still, this would be very hard to do, and he would have to run a crazy long distance because, to give you a reference, the sun is 8 light minutes away from Earth. If we were to take this to the extreme and say that the Flash is running 99% the speed of light, because if you use 100% the speed of light, this equation breaks down, then for every 1 second for him would be 7 seconds for us. The way this equation works is that the closer you are to the speed of light, the less time you experience in comparison to everyone else. And to counterbalance that, there's also this thing called length contraction, but that's a whole other issue. If you want to learn more about length contraction and time dilation, I recommend that you check out Minute Physics' video on it because he explains a little more thoroughly than I do. It's really interesting and crazy concept, and it really makes you rethink things like interstellar travel. Thank you for watching, and go learn something. This video is kind of a new format for me with the whole math and science stuff, which is something that I know a lot about, but I'm not sure if it's something that I want to explore more on this channel. So if you want to hear more about this stuff, just let me know. And if you have some topic ideas, put them in the comments below.